So here's some more work with fractions and how to find the common denominator for a problem. So if we have a problem like 3/4 plus 1/12, we saw how we could use a cross multiplication technique to get the same denominator in both fractions. So if we follow this technique, we're going to multiply the two denominators together, and that's going to give us 48 for the denominators, because 4 times 12 is 48. And then we're going to do this cross multiplication. 4 times 1 is 4, and 12 times 3 is 36. Then we can add the two top numbers, the two numerators together to get 40 over 48. And we can reduce this if we divide it by, it looks like we could divide the top and the bottom by 4. I think so. So 40 divided by 4 is 10. And 48 divided by 4 is 12. This can be reduced one more time maybe. If I divide the top and bottom by the number 2, 10 divided by 2 is 5. And 12 divided by 2 is 6. It looks like that's as simple as I can make that fraction. So that's our answer. But you know, you don't always have to use that cross multiplication technique. Let me rewrite this problem. 3/4 plus 1/12. Your goal is to get the same or common denominator for both fractions. So in this case, we could just convert this fraction on the left, the 3/4, to have a 12 in the denominator. And to do that, we first look at, okay, what would I have to multiply 4 by to make it a 12? Well, 3. So if I write this step like this, 3/3, what I'm saying here is multiply 3/4, the 3/4 fraction, by this new fraction, 3/3. And I think I briefly showed you in the last lesson that when you have a fraction where the same number is in the numerator and denominator, or in other words, the same numbers on the top and bottom, that is 1. It's just 1. And when you multiply any number, anything times 1, it's the same number. It really doesn't change. And this is a difficult concept, I know. But, you know, we're just using this really as a trick in math to help us solve this particular problem. We need the denominators to be the same before we can add these two fractions together. So what this is saying is multiply the top number by 3 and the bottom number by 3. So if I do that, then I'm going to get 3 times 3 is 9, and 3 times 4 is 12. And then I'll write this other fraction that we have, 1/12. Now I've got both denominators the same. Now I can simply add these together using my addition of fractions. So 9 plus 1 is 10, and the denominator stays the same. And you can see I'm at the same point now as my previous problem when I used cross multiplication. And this can be simplified, of course, to 5/6. So we get the same answer. But this technique here of multiplying by this 3/3, or multiplying by this fraction that's really just 1, it doesn't change the value of the 3/4 fraction. It just converts the 3/4 fraction into this new fraction, 9/12, so that I can then finish my problem. Let's do it again with a subtraction problem. So if I had 6/7 minus 3/14. So when you have these fraction problems, you know you can use your cross multiplication technique if all else fails. But look at the problem and ask yourself if you can convert one of the fractions to have the same denominator as the other. So in this case, I see right away that if I could multiply my 7 times 2, it would give me a 14 in my denominator, and then I could continue with my problem. So, since 2 is the number I need to multiply the 7 by, I'm going to multiply this side, or this fraction, 6 over 7, by the fraction 2 over 2. And so if I do that, then 2 times 6 is 12. 2 times 7 is 14. And then I can write the rest of my problem. Now it's pretty easy. I can finish this subtraction problem. So 12 minus 3 is 9. And then my denominator stays the same for addition and subtraction of fractions. And I don't think that can be reduced. I think that's the final answer right there. So let's take a minute and look more closely at this technique, this converting the denominator. In this case, we needed to convert this 6 over 7 fraction to a new fraction with 14 in the denominator. And so you'll see people explain this in different ways. A lot of times they'll say, well, when you need to change the denominator, let's say in this case to 14, you decide what you need to multiply the denominator by, in this case 2, and they'll say, well, okay, multiply the denominator by whatever you need, 14 in this case, and then do the same thing to the numerator, or the upper fraction. And so you can write this in different ways, you can explain it in different ways, but really what's happening is when you're converting these fractions, you're really multiplying by a new fraction that just is really 1. So there's a lot of things we do in math that at first, you ask yourself, well, why in the heck do they do that? It's a lot of these things are just simple tricks that we do, or additional steps we do in order to solve a particular problem. And anytime we can do something like this where we're multiplying a number times 1, or we're dividing a number times 1, it's not changing the value of the number. It's just converting it, or changing in this case, the ratio of the upper number to the lower number. But it's the same thing. So in this case, the 6 over 7 becoming 12 over 14, these are really the same value. They look different, but they're two different fractions, but they have the same value. So that is it's a powerful technique, and you'll see these types of tricks more and more as we go on through the different math examples, and even up into algebra. We do these tricks all the time. So let's look at one more example. Let's do another addition problem. 1/3. Oh, I guess I've got my blue pen. That's okay. 1/3 plus 5 over 21. So when we look at this, of course, we're asking ourselves, okay, which fraction should I convert so I can get the same denominator? And usually you're always focusing on the smaller number, right? You want to increase that smaller number to get it, in this case, to be 21. So I can see that, okay, 3 times 7 is 21, so I need to multiply my 3 times the 7, so that means I'm going to use this 7 over 7 fraction. So in this case, if I do the math, 7 times 3 is 21 on the bottom, and 7 times 1 is 7 on the top, and then I finish rewriting my problem. And now I just add the two top numbers. 7 plus 5 is 12 over 21. Then I want to reduce this to make sure this fraction is in its simplest form. So it looks like I could divide the top and bottom number by 3. So if I come down here, let me rewrite this. 12 over 21. If I divide 12 by 3, I get 4. If I divide 21 by 3, I get 7. And I think that is as simple as this one is going to get. So remember, this technique for converting your fractions is very powerful, and it's very, very, very useful and faster for finding the lowest common denominator in these fraction problems.